In this video, we are going to start with the basic logic gates. Okay, so before I talk about the basic logic gates and how their truth table works, we are going to talk about how logic gates are defined. Okay, the basic characteristic of logic gates. So the things that you have to keep in mind is that each logic gate has a unique symbol. Okay, so each logic gate has a unique symbol. Okay, and a unique function. Okay, each logical gate has a unique symbol as well as a unique function. So they perform the function that are allocated for those specific gates. Okay. So how does these things work? Well, gates can have multiple inputs. Okay. Gates can have multiple inputs. Gates can have multiple inputs. There is no mistake in that. Okay. Gates can have multiple inputs, but the output, on the other hand, is only one. Okay. And keep in mind for not gate, okay, the one we are going to study next, okay, they have only one input normally. Okay. Not gate has only one input. Okay. They can only have one input. Okay. But all gates have one output. Okay. So normally gates can have multiple inputs except for not. Okay. But all the gates can only have one output. Keep that in mind. Okay. And then an input, what do I mean by input? 0 or 1, a single bit. Okay. An input can take only two values. It can either be 0 or 1, and at a time it can be only one value. Okay. Input can be 0 or 1 at a time. Okay. That is very important. Okay. And I said as the logic gates have unique function. Okay. According to the function only. Okay. According to the function only. According to the function, the inputs are processed. According to the function, inputs are processed. Okay. Inputs are processed. And then what happens is you are given with output. Well, we are given with output. Okay. Inputs are processed and output is provided. Okay. Output is provided. Okay. These are some basic characteristics of logic gates. Okay. You have to keep them in mind. Okay. Now let's start with the basic logic gates that we have. Okay. So what are the basic logic gates? First of all, we have not. Okay. First of all, we have not. People start with and, then or, and then go to not. But I normally start with not because it's a very, very important gate and at the same time, very simplest of them all. Okay. So this is the symbol for not gate. Okay. This is the symbol for not gate. Okay. So what happens is you can only give one output. Okay. So let's say the output is A. Well, then the input is A. Well, then the output will be A bar. Okay. Or you can say A dash. Okay. It depends on your preference. But normally we use the bar symbol when we are doing calculations regarding to this. Okay. So what about the truth table? Okay. So let's say this is A. Well, then A bar is the output. Okay. This is the input. A is the input. A bar will be the output. Okay. So truth table is a table where we have a clear understanding for each inputs. Okay. For each input, what will be the given output? Okay. So since A can be 0 or 1 at a time, what will be the output? If A is 0, okay, not A will be 1. Okay. If A is 1, okay, if A is 1, not A will be 0. Okay. So this is the not gate. Okay. This is what we call the not gate. Very important gate. Keep in mind. Okay. Instead of just putting A bar here, what we normally do is we normally represent it as Q equals to A bar. Okay. This Q means output. Okay. This Q means output. Some people use F, some people use Z. That depends. Okay. But for now, let's just keep it with Q. Okay, so this is the not gate. What is the next gate that we are going to look at? AND gate. Okay, AND gate. What is the symbol for AND gate? Well, the AND gate will look like this. AND gates normally takes more than one output. Okay, AND gate normally takes more than one input. So this is AND gate. Okay, this is the symbol for AND gate. So more than one input. So let's say we have A and B. Well, the output can be given as A into B. Okay, or A dot B. Okay, so what is the truth table? Okay, what is the truth table? Well, it needs three columns. Obviously, why? We have two inputs and a single output. So we need four columns. Why? Since there are two possible states for each given input, there are four combinations. So that's why we need four rows for that. So A, B, output is equals to A dot B. Okay, so we'll start with B, 0, 1, 0, 1. A is 0, 0, 1, 1. Okay, so what do we do here? Well, A dot B means we are just multiplying by multiplying each other. So 0 into 0 will be 0, 0 into 1 will be 0, 1 into 0 will be again 0, 1 into 1 will be 1. Okay, so to get the output as 1, okay, the both inputs must be 1. A and B must be 1. Okay, so that's the idea of AND. Next, we are going to talk about OR gate. Okay, next we are going to talk about OR gate. OR gate looks like this. Okay, the symbol of OR gate looks like this. Okay, so this is what we call the OR gate. OR gate also takes more than one input. Let's say A and B in this case. Well, the output can be given as A plus B. Okay, A plus B. So what will be the truth table? Since there are two inputs, we need three columns. For two columns for inputs and one column for output. And then we need four rows to represent all the combinations possible. Okay, so let me draw that first. So we have A here, we have B here, and this is A plus B. Okay, so A, let's start with B, 0, 1, 0, 1. A is 0, 0, 1, 1. So 0 plus 0 is 0. That's what happened. That's what happens when we are working with OR. We just have to add the bits. Okay, so 0 plus 1 will be 1, 1 plus 0 will be 1. We know 1 plus 1 is equals to 2, but we can't put 2, we have to put 1. Because inputs or outputs can have only two states at a time. It can either be 0 or it can be 1. We can't have both of them. Okay, so this is the OR gate. Okay, this is the OR gate. So this is all you have to know about basic gates. Okay, this is enough for basic gates and how logic gates work. I hope you understood what I was trying to say. If you have any doubts in this, okay, if you need more practice or like something like that, please watch the video I have attached to the description. There I have talked about the bitwise operations, okay, which is very, very similar to the given gates here. Okay, in the next video, we will be talking about some combined combined logic gates like NOR, NAND, XOR, and XNOR. So stay tuned.
Thanks for watching the first video in our logic gate series. If you found this introduction to basic logic gates, not and or helpful, don't forget to like, share and subscribe for more lessons. Hit the bell icon to stay updated with our latest videos. Check out the full playlist to master logic gates and follow us on Instagram. I'll see you in the next video. Until then, keep learning and stay curious. Bye-bye.